Chevrolet Series M copper-cooled. The 1923 Chevrolet Series M copper-cooled was an automobile made to be completely air-cooled by Chevrolet in 1923. It was designed by Charles F. Kettering, head engineer of Delco, the General Motors Research Division wing in Dayton, Ohio. The automobile used a body style from its predecessor, but incorporated an air-cooled engine. Air cooling, as opposed to water-based cooling, was much more practical in a sense because it did not require a radiator, nor the piping that came with it. Although air cooling was not new to the time period, it was new to engines of that scale. The copper-cooled Chevrolet was in fact a feasible project, however, the final product did not live up to the standards that Kettering had imagined. The car dangerously overheated in hot weather, and posed a safety hazard to the drivers. Only a few made it to the sales floor, only to be recalled and destroyed by Chevrolet. The 1923 Chevrolet Series M copper-cooled consumed extensive amounts of resources to develop and was a failure in the end. Kettering's blueprints and research led him to believe that his idea was possible. He decided that a cast-iron engine with copper U-shaped fins would give the best cooling, as opposed to aluminum, which is the first choice for modern automobiles. Copper was a good candidate because it is superior at conducting heat. The copper fins would be welded electrically to the engine. Kettering spent extensive amounts of time researching fin patterns that would provide the most efficient cooling, as well as different ways of manufacturing and assembling said fins. Kettering found an overhead valve, OHV, set up to be the most viable engine design. Kettering's OHV engine was an advanced design for the time period. The design was four-cylindered and called for a straight engine configuration. This type of engine allowed for better cooling on the top end of the engine, as well as between cylinders. An issue, however, that arose from this design was finding a place to incorporate the copper fins that Kettering had based his whole project on. To bypass this issue, Kettering took the top of the combustion chamber and incorporated it with a cylinder. This solved multiple issues. One being the space needed for the fins and the other being oil leaks, which were very hazardous to air-cooled systems. Oil leaks in an air-cooled system were fire hazards, as well as health safety hazards, because when oil leaks onto the hot metal surfaces of the engine it creates smoke and could ignite, causing severe damage to the automobile, and its occupants. Also, because of the burnt layer of oil, cooling would be drastically decreased. Kettering understood these concerns and continued to work on ways that would minimize the possibility of an oil leak on the hot cylinders. He found that the best solution was to have only one possible leak site above the cylinder heads. That is the joint between the crankcase and the cylinder. This left almost no oil above the cylinders, and only one possible place for a leak to spring. This significantly reduced the risk of an oil leak, as well as allowing mechanics to locate a possible oil leak much more efficiently.